Okay, today we are going to go over our 3.4 notes, solving multi-step equations. I'm going to go ahead and start with name and class period. And as always, these notes will be available in the on the Google Drive. You'll have access to them on Schoology. So first up, we need to talk about combining like terms. These two parts should be a quick review, but we are going to go over them just in case. So combining like terms, you've got two steps. You're going to add the coefficients, and then you're going to keep the variables. When you're adding coefficients, you're looking at the numbers. And when you're keeping the variable, you're looking at the letters. So if we were to look at the example of, let me go ahead and zoom in here a little bit more for you. If we were to look at the example of let's look at 3x plus 7x minus 1. 3x plus 7x minus 1. I'm going to underline the 3x and the 7x in a certain color. I'm going to underline my negative 1 or my minus 1 in a different color. The reason I'm doing that is because my 3x and my 7x are like terms. They both have an x. My negative 1 is just a plain old number. There's nothing I can combine it with. And I definitely can't combine it with my 3x and 7x, so it gets its own color. So now, when we're combining our like terms, we need to add the coefficient, which we know is the number. So for 3x, my coefficient is 3, plus my coefficient for 7x is 7. And then I put my x afterwards, because I kept my variable. And then at the end, I need to put my minus 1, because I can't just get rid of it. It's still part of the expression. I know now I can simplify it even further. So I have 3 plus 7. I know that's 10. And then we know that this is parentheses with an x afterwards. That's multiplication. So I could just say 10x, because that also means 10 times x. And then we have minus 1. So our answer for this one, our simplified version, once we have combined our like terms, is 10x minus 1. Okay, go ahead and if you need some more time with that, hit pause. If not, we're going to move on to the next one. The other skill that we need to go over is distribution. For distribution, you're going to multiply the number outside of the parentheses look like that, remember, by each term inside of the parentheses. So you're going to multiply outside of the parentheses by each term inside. Let's do an example. If I have 1/2 times 6x minus 10. So remember, this is just like if we had just a 3 in here inside the parentheses. It would be 1/2 times 3. This is 1/2 times 6x minus 10. Okay. The first thing that I need to do to show that I'm going to be distributing is I got to get my arrows in. So I'm showing that I'm going to distribute my 1/2 to my 6x and to my negative 10. Not a regular 10, it's a negative 10. Let's see. First off, and let's go ahead and assign these colors too. So my 6x and then my negative 10. So that'll help us keep it organized. So first off, I need to deal with my 1/2 times 6x. I'm going to open some parentheses. I know I'm going to have 1/2 times. I also know that this is 6 times x, so it's actually going to be 1/2 times 6 times x. Okay? Then you're going to do a plus. You will always do a plus in between. And then we're going to deal with our other one, which is going to be 1/2 times -10. Okay? So we've distributed it. Now we need to simplify it. So we deal with what's inside the parentheses first. If you needed Desmos, this would be a good time to put 1/2 times 6 into Desmos, or you could think about it as 1/2 of 6 is 3 times x. So that first part becomes 3x plus, okay, I know my answer is going to be negative here because I have a negative times a positive. So it's going to be negative 3x plus, you could do 1/2 times -10 again in Desmos, or you could think about it of, hey, what's half of 10? That's 5, and I know my answer is negative, so 5. There's one more thing we can do to simplify here. I have 3x. This plus minus 5 plus minus always turns into a minus 5. So 3x minus 5. Plus minus always turns into a minus. Okay, go ahead and get that one if you need, go ahead and pause if you need to get that one. As a reminder of our steps, some of the steps we're going to go through today, we are going to go over when we're solving multi-step equations. First, you're going to distribute if you can. Then you're going to combine like terms if you can. And remember, these happen on one side of an equal sign. They don't cross over. Then you're going to start adding and subtracting across the equal sign. That's where we start doing what you do to one side has to be done to the other. Adding and subtracting, trying to get that variable by itself. And then multiplying and dividing, trying to get that variable by itself. Okay. We're going to do some examples. Do some combining like terms examples pretty quickly because, again, this is a review. So let's say we have 7x. Do I have any other x's in here? Oh, I see a negative 2x, and I see a positive x. Okay? Some of you guys may already see it. Give it a second. And then there's a 5y. So I know that I need to add my coefficients. So I have, let's do my x's first. I have 7. That's not 1. Minus 2. Okay, so I've dealt with that. That doesn't get combined. That, uh-oh, what's going on here? What's my coefficient for x? It's an invisible 1. So 7 minus 2 plus 1. And then there's nothing really to combine the 5y with, so you can do just plus 5y. Oh no, I forgot something. 7 minus 2 plus 1, x. Can't forget my x. Okay. 7 minus 2 plus 1 would be a great opportunity to use Desmos. So you have 7 minus 2 plus 1, I'll go ahead and tell you right now, is 6x plus 5y. Go ahead and get that one copied down if you need to. example 2, we have 2a minus 12 plus 9 minus 5a plus b. Whew, there's a lot in here. Let's just start with that first one. 2a, going to underline it. Does it have any like terms? Negative 5a. Okay. I don't see any other a's, so we'll switch to a new color. We have a plain number, negative 12, doesn't have any variables, and we have a positive 9. And then, oh, this is a b, so it can't be added in with those because it's not just a plain number. It is a variable. But it's not an a, so it's its own type over here. Okay. So let's start with our 2's, or our a's, I'm so sorry. So we need to add our coefficients. So we've got 2 minus 5a. And then just to stick with our variables and like go in alphabetical order, I'm actually going to do my plus b right here. A lot of you may have wanted to put a 1 in front of that b, but do I need it? Am I trying to get my coefficient? If I'm not trying to get my coefficient from that b, I don't really need it right there, do I? Because I'm not adding or subtracting it from anything. And then last but not least, we're going to do plus negative 12 plus 9. Okay, so that one was a little tricky. We dealt with our 2a, because we have 2a. We dealt with our negative 5a, so we've dealt with those terms. We dealt with our negative 12. We dealt with our positive 9. And we dealt with our b. So we got them all. Sometimes it helps to do a little checklist like that. Okay, 2 minus 5 is a great opportunity for Desmos. It's actually negative 3a plus b. And we're going to do plus negative 12 minus 9 is actually, or I'm so sorry, negative 12 plus 9 is actually negative 3. Okay, do you remember from earlier on what that plus minus can turn into? See if you can remember. Did you remember? It turns into a minus 3. That plus minus will just turn into a minus. So this one, negative 3a plus b minus 3. Now, what if you had done your b in a different place? That's okay. What if you had done your b at the end? Yours would have said negative 3a minus 3 plus b. Oh, I didn't do the colors on that one, but you get the point. Either one of those is correct. As long as you're keeping the sign with the term, you're good. Okay, give you a chance to pause if you need to catch up on that. We're going to do some quick distribution examples. These should be super, super quick. So remember, we need to take the number outside of the parentheses and multiply it by each number, each piece, each term. Each term inside of the parentheses. So our 7 has to get multiplied by x, and it has to get multiplied by 4. So we end up with 7 times x plus 7 times 4. 7 times x turns into 7x, plus 7 times 4 is a great moment for Desmos, and that is 28. 7x plus 28. And our last example here, distribution. This is, I want you to pay attention, this is a negative 2 that has to get distributed. So it's a negative 2 times x, and it's a negative 2 times negative 9. So this is why it's important to start writing these things out in these steps. Negative 2 times x. So I can see that I did my negative 2 times this one. This is always going to be a plus in between when we're doing our first step in distribution. Negative 2 times negative 9. You don't want to start goofing around with this plus sign because you always want to make sure that you're getting your negatives and everything inside here exactly as they appear up here. So here we have a negative 2 and a positive x, negative 2, positive x. Good stuff. Here we have a negative 2 and a negative 9, negative 2 times negative 9. Okay. Negative 2 times x, just like 7 times x is 7x, this is negative 2x. Plus, great moment for Desmos, negative 2 times negative 9 is a positive because it's negative times negative. So plus, we don't have to add any other signs here, it's 18. Okay. If you need those copied down, go ahead and get them. Hit pause and grab them. Okay. Now we're doing examples. And before we get started, I'm going to go back and refresh my memory on that chart from the front. We're going to start with distribution, then we're going to combine like terms, then we're going to add and subtract, and then we're going to multiply and divide. And I'm actually going to write that at the top of my paper. D to help me remember, oh, so sorry. D to help me remember to distribute, C, A, S, M, D. Anybody can help me come up with an acronym for that? Kind of like we have PEMDAS. I have yet to come up with one for this. So, very first thing, when I am solving an equation, I got to draw my gate so I know what my two lines are, or my two sides. So sorry. So, this side isn't going to change at all. It's going to be 10 equals. This side, do I have any distribution? By golly, I do. So I know that I need to distribute my 5 to my x and my 5 to my negative 3. So I'm going to come up with 5 times x plus 5 times negative 3. And this is distribution. So let's see if we can simplify that a little bit. I know that 5 times x is 5x plus 5 times negative 3 is going to be a negative because positive times negative is a negative. 5 times 3 is 15. So I've got one more thing I can do. See if you can remember what that plus minus turns into. Got 10 equals 5x minus 15. Okay, so all of that was our distribution. That took a minute, didn't it? Okay, so that was our first step. So now we need to see, can I combine like terms? There's nothing I can combine on that side. There's nothing I can combine on that side. So nothing there. So my next step, is there anything I can add or subtract? And now I'm doing my balancing on both sides. Anything I can add or subtract to both sides that's going to start to get this variable, which is my x, by itself. So this says 5x minus 15. I know that I can undo that minus 15 with a plus 15. I do it to that side of my equation. Need to do it to that side. So that gives me 10 plus 15. Great moment for Desmos. 25 equals, my 5x does carry down. and then these two cancel out. So I've done my adding and subtracting, and now I still don't have my variable by itself. So I'm going to go ahead and look, is there anything I can multiply or divide? I need to get rid of this 5. This means 5 times x. So if I divide both sides by 5, that inverse operation, the inverse of multiplication is division. I know that those will cancel out. That will give me x, and then 5 divided by, 25 divided by 5, great moment for Desmos, would be 5. So 5 equals x. Our first step was distribution, and that carried us all the way down to here. And then we had to add, and then we had to divide. So we got all of our steps done in order. Go ahead and pause it there if you need to grab the work. Okay, let's look at example 2. Okay, so here we have, let's go ahead and write our DCASMD. DCASMD. We distribute, we combine like terms, we add or subtract, we multiply or divide. Okay, and we draw our gate first. Now, is there anything I can distribute? I don't see any parentheses or anything. Like over here we had some parentheses and we could do all that. I don't see any of that. So we cannot distribute. But we can do some combining of like terms because we have an x and an x and they're on the same side. So let's do that. So combining like terms, we add the coefficients, which is the numbers. So we have 6 minus 2x equals -8. Six minus 2, great moment for Desmos or for a little fingy math. 6 minus 2 is 4x equals -8. So we have combined like terms. Now, is there anything I can add or subtract from this side that's going to start to get my variable by itself? There's nothing being added or subtracted. So there's not really anything I can add or subtract. Now, is there anything I can multiply or divide? Because this x is being multiplied by 4. I know that the inverse of multiplication is division. And if I divide both sides by 4, I can undo that. So my 4x divided by 4 just turns into x equals -8 divided by 4 is a great moment again for Desmos. I have a negative divided by a positive, so those are different signs. I know my answer is going to be negative. 8 divided by 4 is 2. X equals -2. Oh, I'm so sorry. Go ahead and pause there if you need to get caught up. Okay. Example 3. Let's write my steps in order. D, C, A, S, M, D. Draw my gate. Let's go. So I can do some distribution because I have a number outside of some parentheses. So I can distribute my 3 to my x and to my 6. Now, I do not distribute my 3 to my 2x. It only goes to the numbers in, or the terms inside of the parentheses. Okay? So this turns into 3 times x plus 3 times 6 plus 2x. That 2x still has to stay there, though. Equals 68. Okay? So my 3 times x turns into 3x plus 3 times 6 is a great moment for Desmos if you don't know it off the top of your head. 18 plus 2x equals 68. So my 3 times x turned into 3x, my 3 times 6 turned into 18, and my 2x stayed the same. So now I have distributed. Okay, now I need to look for combining like terms. Are there any like terms that I can combine on this side? Yes, ma'am, there are, or sir, whatever you choose. So we got 3x and we got a 2x we can combine, don't we? So I need to add my coefficients, which is my number parts, 3 plus 2, keep my variable x plus 18. She didn't space it very well, but you get it. So this is taken care of, that's taken care of, 3x, 2x, 18 is taken care of. It's going to equal 68. Okay. 3 plus 2, Fingy Math and or Desmos tells us that it's 5x plus 18 equals 68. Okay. And that was combining like terms. CLT, combining like terms. So now we've distributed, we've combined like terms. Now we need to see if there's anything we could add or subtract that's going to start to get our variable by itself. So is there anything on this side that could be added or subtracted? Well, yep, because we're adding an 18, we need to subtract that to get rid of it. Got to do same thing to both sides. So minus 18, that cancels, our 5x comes down. $68 minus 18, great moment for Desmos. It's going to be 50. Okay, so now I've added and subtracted. I had to subtract on that one. And now I have 5x equals 50. And I know that 5x means 5 times x. I want to get rid of that 5, so I need to do the inverse of multiplication, which is division. Divide both sides by 5. Bring down your x. Equals 50 divided by 5. See if you know it. It's 10. So x equals 10. Go ahead and pause there. Make sure you're caught up. Oh, hold on. And I did do my multiplication and division. Okay. And last but not least, example 4. Remember our order. We have D, C, A, S, M, D. Let's hit it. Let's draw our gate. Is there anything we can distribute? Yes, there is. This 5 can get distributed because it's outside of the parentheses. It can go to that x and that 3. But we still have to keep our 3 plus there. So 3 plus 5 times x, there's our 5x, plus 5 times this 3 equals 18. Let's simplify that a little bit. We have 3 plus 5 times x turns into 5x, plus 5 times 3 turns into 15 equals 18. Okay, that was distribution. Now let's see if we can combine any like terms. There's not anything to combine over there. But over here we have a 3, we have a 5x, and we have a 15. Oh, we have two plain old numbers we could combine, don't we? Okay, so let's do, let's go ahead and write our variable first, just so we don't forget it. 5x plus 3 plus 15. And there isn't a number or a letter behind that because there's no variable there. And that equals 18. 5x plus 3 plus 15 is 18. Great moment for Desmos if you didn't know it. Okay, so now we have 5x plus 18. These parentheses, nothing's really going on inside of them, so we can just say 5x plus 18 equals 18. And that was combining like terms. CLT, combining like terms. So now we need to see, is there anything we can add or subtract? Well, we have our variable, but we're adding an 18 to it. So let's try getting rid of an 18. 18 minus 18. This is looking a little interesting. Hold on here. Let's see. Okay, so I know that that carries down 5x equals, and this cancels out because technically 18 minus 18 is 0. And if I say anything plus 0, that doesn't really change the amount, so I don't have to write it. But we have 18 minus 18 over here, and we have to have something here. We can't just leave it blank. That equals 0. 18 minus 18 does equal 0. Interesting. Let's keep going. We don't usually get zeros, but let's see what we do. Now, we need to get rid of our 5 times x, so we can divide both sides by 5. This does bring our x down. Oh, and then this is 0 divided by 5, which I remember way back to one of our rules. 0 divided by anything is 0. So x equals 0. So even though that one was a little different, we did have an answer. Okay, go ahead and hit pause so you can get your answer or get your work shown. Oh. Okay. Last but not least, you guys do have some practice problems that you will work on your own. Let me know if you need help. And that is solving multi-step equations. Yay! Have a good day.